We are back. Today we continue our investigation into the most expensive PRs in the Apache NUTX project. What do we mean by most expensive PR? These are the PRs that consume the most time of our GitHub runners. These are the longest running GitHub jobs for GitHub Actions. Over the past couple of videos, we looked at the top 3 most expensive PRs during the busy period of December 2025 as well as January and February 2026. Today, we will shift repos. Instead of looking at the NUTX repo, we will now go into NUTX apps. Just to recap quickly what happened in the last couple of videos, the most expensive PR, the number 1 most expensive PR, we experienced mostly download failures and NTFC failures. That's why we are proposing to build a retry mechanism like this that will retry our jobs, retry our NUTX targets, the building of NUTX targets up to 5 times, so that if there are any download errors in the building of NUTX target, hopefully our retry will fix that. Then for the number 2 most expensive PR in the NUTX repo, we hit mostly compile errors. Then we said that we have a way to manage this. We had rolled out a new tool called Manual NUTX CI that allows us to build and test PRs in our own repositories. With this new tool, we will be able to build and test PRs in our own repos, make sure that the build succeeds 100% before we submit it to the Apache NUTX repo. Therefore, we should not see any more such problems, compile errors, when we submit PRs to NUTX. Then we looked at the 3rd most expensive PR in the NUTX repo. We saw that there was a mix of download errors as well as NTFC errors and compile errors. Download errors will be fixed by the retry mechanism that we spoke earlier on. NTFC download errors, as we are speaking right now, we have just rolled out a new version of NTFC downloads that uses the pip package management system in Python. We are now monitoring the outcome of the rollout. Hopefully, we should not see any more NTFC download errors. We also see compile errors, which we think can be fixed by our new way of testing PRs in our own repo. Ideally, all of us should test PRs in our own repo, make sure that the build is 100% successful before we submit the PR to the Apache NUTX repo. And that was the summary of the 3 most expensive PRs in the NUTX repo during our peak period earlier this year. Moving on, we need to look at NUTX apps now. We wish to understand if NUTX apps are any different from our NUTX repo. This is the most expensive PR in our NUTX apps repo, PR number 3315. Let's go into the PR now. We have created a spreadsheet for 3315. How did we create this spreadsheet? Well, we just took one of the existing PR analysis book spreadsheets. We made a copy. Then we edited the pivot table. In the pivot table, we selected a different PR number. You can see here that the PR number is now 3315. This is what we clicked. Once we click that, it will select PR115. 3315, sorry. PR3315 looks like this. Today we are not going to we're not going to blame any particular person or any particular developer, anybody in the Natex team for consuming too many resources. We are looking more at the quantitative data. We need to understand why this PR was taking so much time to build. This PR was merged in January. Let's go in and see what happened. These are the build jobs that happened for that particular PR. In total, we saw 20 build jobs for that PR, consuming a total of 34 hours of GitHub runners. This is the elapsed hours for GitHub runners. We have a factor of 7.4, meaning that we take 34, multiply it by 7.4, and this will give us the actual GitHub runner hours that are charged to the Apache Natex project. Therefore, this is the actual number that will count towards our utilization of GitHub runners. We saw a peak in January and February 2026, earlier this year. Those hours, the 200 over hours, they contributed to this peak here. That's why today we are analyzing what happened in those 252 GitHub hours that were charged to the Natex project. Why did we consume so many hours for this one single PR? Let us scroll up to the top and see what happened. Now the first failure here is a download error. Let's see what happened here. When we go into the PR, the build, we will see, let's scroll up and see what download failed. Yeah, it's trying to build the target for MQTT for ESP32, and the download failed. It's trying to connect to codeload.github.com, and there's a timeout. Unfortunately, we're not able to see what exactly failed the download. It's trying to download something called 1.1.5.tar.gz. However, it doesn't say whether this is an ESP32 runtime, and this could even be some MQTT library because it's failing due to MQTT error here. We're not sure what download failed here, but we know that this job failed due to a download error, and as a result, it cancelled all the other jobs. This is very bad. The good news is that we are now testing our new solution of doing the rebuilds for the target. Once this has been rolled out, it will rebuild the target and it will re-download any dependencies required. And hopefully this will solve our problem. We have we've just seen one download failure here. Let's move on and see what happened to the rest of the failures. This is a compile error. Let's go in there and take a look. If you go into ARM64, let us scroll up and look for the error. Going up, we see that there is a SIG-info undeclared error. This is obviously a compile error, right? Our recommendation is that our developers should now use this new way of doing a manual build of PRs in our own repos before submitting to the Apache Natex repo. That way, we shouldn't see any more compile errors. Moving on, we will see this failure here. Let's click inside. The job that's failing is MSBC, which is quite unusual. Now, this is totally odd. I have not seen this before. We can see that it's... Let's try to expand this. It's trying to download something from some server and it's failing. When we expand this, we see that it's trying to download the GCC toolkit for Windows and it's failing. Right. So this qualifies as a download error. In future, our retry mechanism that we spoke about earlier on, it might be able to fix this error. However, that's not our priority right now. Our fix is mostly for bash script running on Linux. We haven't actually done any fixing for Windows builds yet. So in future, this might be something that we look at. But in general, we don't see that many download failures for Windows builds. This is super unusual, highly unusual. If this happens quite often, we will need to address this by doing a retry of the job, or retry of the build for this target. Therefore, we have seen a failure here for GCC downloads for Windows. Very unusual, but now we see that GCC Windows is also having download issues. Are we having the same issue here? Let's take a look. If we click into the log here, again, MSPC is failing. And what is the error for MSPC? Same thing. It's exactly the same issue that we saw earlier on. It tries to download GCC for Windows and it fails. This is very interesting. It failed twice. Twice in a row. So that's something that we have to address in future. This could happen again. Moving on to the next failure. This we believe is a compile error. Let's go in and take a look. We see here that ARM03 failed. If we scroll back up, we can see the error. Yeah, there you go. It's yeah. These look like legitimate, really legit compile errors, which we need to fix by doing a local build in our local repos. That is definitely one compile failure. We believe there's another compile failure here. Let's verify that. It seems to be the same job that's failing. And yeah, it's a similar error. We see here that there are, wow, 1, 2, 3, 4, 5 compile errors. In between, there's one success. This likely means that our developer required 4 fixes, 4 recommits, and 4 rebuilds to hit a success status, to eradicate, to eliminate that compile error. But after the build was successful, it's highly likely that one of our PR reviewers requested for a change in the code. That's why our developer made some more changes and resubmitted the PR, causing a failure. Now, these 4 particular failures here, in future, if we make use of the manual CI test method, we should be able to eliminate all 4 rebuilds. The idea is that our developers will be able to test the PR containing the changes in our own repo. The 4 rebuilds that will happen will be just a local build in our own local PR. We would advise the developer to switch this PR into draft mode so that the PR's commits that happen here will not be compiled during draft mode. When the compile errors have been resolved by our developer, we should change the PR into ready for review mode. That way, we will trigger an actual compile in our Nutex main repo, and that will succeed. In the last video, I spoke about a possible way of doing the to ensure that we don't do builds of PRs while the PR is in draft mode. I will go a bit more details into the mechanism. We don't have a very neat mechanism, but we have something that might work. Therefore, we have 4 build failures here that could have been resolved if we allow our developers to to test the PRs locally in our own repos before submitting to NATEX. We have one more compile error. Is it the same kind of compile error? If we, again, ARM03, yeah, it's quite similar. This particular PR happened to have some issues with ARM03 and it took a while to resolve. Yeah, but actually it's not that bad. It's, compared to some of the other PRs we've seen in NATEX, this one was quite short. It required 20 rebuilds to succeed before this whole PR was committed. Now, the thing about NATEX apps PRs compared to NATEX PRs is that NATEX apps will do a full build. For NATEX PRs, when we talk about making changes to the NATEX kernel, there's an option of doing a selective build, meaning that if we see that this particular PR is for a ARM platform, for example, our CI scripts will select the appropriate platform for ARM and build only the ARM platform. We call this a simple PR for a simple build. However, for NATEX apps PRs, there is no such thing as a simple build. Every single NATEX apps PR, even the very simplest PR, will trigger a complete build, a complex build across all architectures, which means that our builds for NATEX apps will always be at least 3.5 hours long. That's because it needs a time to cover through all the platforms. For NATEX kernel PRs, our builds can be quite quick. Depending on our platform, it could be 1 hour or 2 hour plus. Only complex builds will take 3.5 hours, whereas NATEX apps PRs will always take 3.5 hours, which explains why it doesn't really seem to be that many rebuilds. 20 rebuilds is not a lot, but yet this thing counted as the number one most expensive PR for NATEX apps repo, and it's quite comparable to some of the other expensive PRs in the NATEX repo. That's why we have to watch out for NATEX apps also. NATEX apps, even though they undergo fewer rebuilds, but they will incur a lot of GitHub runner hours simply because every build is a complex build. Every build will require 3.5 hours. That's why we see NATEX apps near the top of the expensive PR list. However, again, in one of the earlier videos, we've done the detailed analysis. We discovered that NATEX apps don't actually take up that much time. We have it here. In one of the videos, we discovered that when we compared NATEX repo versus NATEX apps, NATEX repo was still taking most of the compile time, 84%. And only 16% is coming from NATEX apps. Which means we should still focus our attention on NATEX repo, not NATEX apps. But the exercise today was quite helpful because now we understand the pattern for NATEX apps. Yes, individual builds for NATEX apps repos will take a long time, 3.5 hours. But today we've seen that there were some compile errors. In fact, mostly compile errors. And if our developers were to use our new way of building and testing PRs in their own repos, then we can conserve all the time that was wasted on recompiling NATEX apps PRs that were wasted because due to compilation errors. In case you're curious, we made a comparison also of the usage of our GitHub runners for NATEX versus NATEX apps repo. We compared the past year data for the past 12 months. We also compared the past 4 months. Why the past 12 months? This coincided with our peak period. And we noticed that the pattern is exactly the same. It's 84%, 60%. So it's quite similar. Which means that even though we are having a peak period, we were still spending a lot of time compiling NATEX PRs as opposed to NATEX apps PRs. Therefore, we are paying more attention to our our PRs in the Nutex repo as opposed to the Nutex apps repo. In any case, today we have come up with a very satisfying analysis. We have seen the most expensive Nutex apps PR. We can see that majority of failures were due to compiling errors. 1, 2, 3, 4, 5. 5 compile errors. 6 compile errors. We saw some download errors. 1, 2, 3. So we had 6 compile errors and we had 3 download errors. Download errors, we have a solution for that. We are compiling it with our retry mechanism, meaning that any download failures will just simply go through the retry. For compile errors, we will need to do this manually. There needs to be manual intervention. Our developer needs to be able to build and test the PRs successfully in their own repo before submitting to Nutex apps. If all developers do that, hopefully we won't see this situation anymore, and we should conserve a lot more GitHub runners for Nutex apps PRs. We have just seen a very quick analysis of the most expensive Nutex app PRs. And in fact, that should conclude our analysis of the most expensive PRs. One reason is that our logs are expiring. Some of these PRs that were done in December have expired. The GitHub will not maintain our logs after 3 months. That's why some of the older logs are expired. We no longer have a way to trace, to roll back and find out what happened to those PRs at that time. What were the errors? The logs are simply not available. We couldn't see the errors. Moving ahead, we have to push on and do other things. Since we are done with our analysis of the most expensive PRs, we will now push on to talk about the monitoring of PRs. In our last video, we spoke about building a new live monitoring dashboard for Nutex PRs. With this dashboard will show a live list of PRs that have just been submitted but not yet committed, not yet merged. We need to be able to monitor them in real time, meaning that we should be able to see, for example, how many builds this PR has gone through. If we see that this PR has gone through many builds, like 56 here, we need to flag these out and do more investigation. Why would a PR going through so many builds? It could be one of these errors, one of these problems. Firstly, it could be a download error. Maybe the PR failed many times because it tried to download a build dependency, but it failed. Maybe it failed 10 times trying to download a dependency. Our new retry mechanism is designed to resolve this. With this retry mechanism, we should no longer experience any download failures. But we have to monitor to make sure that our downloads are still going through correctly. We have another reason for going through so many builds is that we could have been experiencing NTFC errors. We saw in the previous video that some of our NTFC downloads, NTFC is our framework for CI tests, the CI test that calls QEMU in our GitHub Actions. The NTFC download fails sometimes because it tries to update the Ubuntu packages, and Ubuntu repo for packages is kind of unreliable. Sometimes it just fails, and we have seen a couple of failures in the past. Today we have rolled out a new mechanism. We no longer do the updating of the packages through the Ubuntu repository. We are now doing it through the pip package manager. We are now monitoring, so hopefully with the new pip system of downloading NTFC framework, we should not experience any more NTFC errors. We are monitoring, and we'll make sure that's the case. A build could also fail because of compile errors. Like we saw early on, our most expensive PR for Nutex apps experienced 6 compile errors. Now, this needs to be manually flagged out. If we see a PR with too many compile errors, that's when a NUTX maintainer will need to do manual intervention. We will need somebody to remind our developer, let's put this PR into draft mode and let's do a local build in a local PR. Remember this? We would like the developer to build and test PRs in their own repos, make sure that we fix all compile errors before we push the commit and do a proper successful rebuild in the NUTX main repo. Then comes an interesting question. We are putting in some new functionality here. When the PR is in draft mode, we do not wish to compile the PR. But yet our developer will continue to push new commits while they're making fixes. How do we prevent PRs in draft mode from getting recompiled in the NUTX main repo by GitHub Actions? In the last video, I talked about this process here. We need to run some kind of a background job. This is not running at GitHub. This will be likely running on my computer. What we'll do is that our computer will do a scan. It will keep calling the GitHub API to fetch a list of draft PRs. When it sees a list of draft PRs, it will fetch the GitHub jobs that are associated with these draft PRs. Then it checks, are any of these jobs running right now? If any of the build jobs are running for draft PRs, then our batch process will terminate all these jobs, which means that we have effectively a mechanism that prevents draft PRs from getting compiled in our NUTX main repo. Our developers could continue to push new commits as they change the code, but as soon as our batch process here detects that a draft PR is triggering any GitHub Actions jobs, it will kill them, which means that we will conserve our GitHub runners. We will no longer incur costs compiling and running GitHub jobs for PRs in draft mode. Only when the PR is switched from draft mode into ready for review, then we allow the jobs to continue. And by the way, we will also post a comment to the PR. Our batch job will post a comment to the PR to tell a developer that we killed your jobs because it's in draft mode. As a courtesy, right? We should tell them what happened when the jobs get killed. It's not a very elegant solution, but I think it's the best we can do right now. We have lots of resource issues. We have limited people in maintaining NUTX CI. This system is running outside of GitHub, meaning that it will likely not break anything existing in GitHub. Right now, our CI processes are extremely complex. We are running a lot of legacy scripts. Any of these legacy scripts might break, and we are very worried for that. That's why we are trying to run this as much as possible outside of GitHub, so that we don't disturb the existing legacy scripts. How will we do this killing? We have tried this killing a while back. During the peak period 1 year ago. So that was the time that we got a reminder from ASF Infra team that we need to fix our NUTX CI, otherwise they'll terminate our access within a couple of weeks. That's when we came up with this script. You can find the script in the NUTX release repo. The script is called kill push master. What we were doing at the time was that we are looking for any merge jobs. So we discovered that our merge jobs were taking a lot of time. We're taking too many GitHub runners. We wanted to kill the merge jobs and move them out into another repo, which is our NUTX mirror repo. To do that, we have to do a scan to find out all jobs that were running in a NUTX repo that were pushing to the master branch. This means that this command will identify a list of GitHub jobs that were triggered due to our push to the master branch. In other words, these are the merge jobs. And we issue this command, GitHub run cancel. We pass in the repo name and we pass in the run ID. The run ID is the job ID that was returned by this command here. And this is how we kill a job. We've done this before 1 year ago, and therefore we can do this again for our new setup. Except that we will now change this. We will now watch out for draft mode, PRs in draft mode. And if we find any jobs that correspond to jobs in draft mode, that correspond to PRs in draft mode, we will do a cancel. Now, just to note that this cancel requires like super user privileges. We will not be able to use a normal ID to kill it. I will have to run this using my own Nutex admin ID so that it has sufficient privilege to do a cancellation. And in our new setup, we will no longer be running this. Pushing to the master branch has been permanently disabled. We changed a rule in our build.yml in our GitHub Actions. Therefore, we will never ever do this again. But we will now have to put this into our own script to monitor for draft PRs and any jobs that they trigger. That's why we think that this thing is not very elegant, but we have a solution. We use it before, and we think it'll work. Killing of jobs is pretty effective when you have a script like that. Let me go into more details about this part here. Moving ahead, how will we implement this Nutex PR monitor? We have lots of data here. We have PR number, we need to count the number of builds, number of errors, and so on. How are we going to do this? In the past video, we said that this dashboard, this live PR monitor, will be rendered by a Grafana dashboard. It's open source dashboard software. It's very similar to our Nutex dashboard. Our Nutex dashboard today renders any build errors coming from our Nutex mirror repo and our Nutex build farm. We will reuse the same software on a different server to render our Nutex PR monitor. The data source for our Grafana is coming from a Prometheus database. Prometheus is more like a JSON type kind of database, not really structured, but it's very commonly used for storing monitoring data. Folks who are familiar with infrastructure monitoring, we will hear Prometheus a lot. It's used mainly in the world of system infrastructure monitoring. We are monitoring batch jobs here in Nutex. Therefore, Prometheus seems like a good choice for doing that. Now here comes the tricky part. We need to populate the data in Prometheus so that it will be rendered by the Grafana dashboard. How will we get the data into Prometheus in the first place? We need to run a process in some cloud server, probably Google Cloud. We will need to run a background process, a background job that will run forever, reading the PRs by calling the GitHub API, reading all the job status from GitHub API, matching them up, and doing some kind of matching and processing to come up with these numbers so that we can inject them into the Prometheus database. How will we do this processing part to get the PR and job data? We have some ideas. We have done this in one of our earlier videos. We created a dump of PRs, jobs, and the job durations from the Nutex repo as well as the Nutex apps repo. We have scripts here. We have a script called dump GitHub jobs, and we have some Rust script that will do the matching. What is the output of this? This creates a TSV file. This particular TSV file. If you are curious what a TSV file looks like, we imported this into our spreadsheet in Google Sheets. We'll see that it's a combination of the job status. So this tells us the job status, the job ID, the run ID, the status, as well as the runtime, run duration in milliseconds. Our script has helpfully joined the batch job, the GitHub job, together with the PR details. We will get the PR URL, the PR title, and so on. Notice that the PR repeats a few times. That's because one PR can trigger off multiple jobs. And this is how it'll work. We have the way to do an export of the PRs and jobs and do the matching. We will use this script, we'll modify this script to be able to do this thing here. We need to dump the PRs and jobs from GitHub and do some matching. Now, this matching will just provide us the GitHub jobs and the PRs that trigger them. But it will not tell us what happened. It will not tell us whether it was a download error, whether it was an NTFC error or a compile error. This requires us to use a different script. Remember we spoke about the NuttX dashboard. This NuttX dashboard today doesn't monitor PRs, but it monitors the status of our builds in our NuttX mirror repo as well as the NuttX build farm. These are PRs that have been merged, that have been committed into our NuttX main repo. Today, when we go into any of these messages, we can see that it will extract the warnings and error messages very helpfully, and they appear here. Today, we don't really have a standardized way to extract errors and warnings from our GitHub logs. Fortunately, because of the NuttX dashboard project, we have created a script that will do that. This is the script. In just NuttX builds, we have a Rust script that will extract the messages. And it's not pretty. It looks pretty complex. Let me show you why. Our logs have error messages, yes, but there are lots of other messages in there. And we need to distinguish normal messages like this versus an actual error. So this is a normal message that we expect to see in the NuttX build log. However, there are error messages that we want to extract. And there's no fixed pattern. So that's why we see that it's messy because we have these things here. You see this? This logic tells us that in order to identify errors and warnings, we need to ignore these lines. If it sees something called cleaning, configuring, select, disabling, and so on, it means that this line corresponds to a normal message in a NuttX build log. These are not warning messages. These are not error messages. Phew. And you can see that there are a lot of these patterns. The idea is that whenever our script sees any of these patterns, it will not treat it as a warning or treat it as an error. If a particular line in our NuttX build log fails to match any of these patterns, then it's probably a warning or an error. And that's when it gets flagged out. And in fact, in the code below, we can see that it's pushing the messages to our Prometheus server. And we can reuse some of this code. So we need to be able to scan through the logs. We need to be able to identify which are the errors and warnings. But to do that, we need to skip all the lines that are not errors and warnings. That's why we need to reuse this whole logic here. Then at the end of the code, once we have compiled a list of errors and warnings, we need to push it to Prometheus. The way we push to Prometheus is through, there's a long code here, but it's essentially a HTTP request here. This means that, good news, we can reuse this logic, right? We are doing the same thing here. We are running a process here to do the matching of PRs and jobs. Then we need to fetch the logs. I'll explain how. We need to do the matching that we've seen earlier on to filter up all the normal NuttX build messages, identify the errors and warnings. Then we will push the errors and warnings into our Prometheus database. That's when our Grafana dashboard can do some kind of some kind of pivot table, some kind of matching again to count how many errors, how many NTFC errors, download errors, compile errors. And that's how Grafana will render this table here. It sounds kind of complicated, but I think we have all the pieces here and there. It's just a matter of matching them up and running them in the cloud. There's one last thing we need to think about. We need to be able to fetch not only the job status, but the actual log for the job. That's where we need the log so that we can do the matching. How will we get the log for the builds in GitHub? We have the script here. Again, in just Natex builds, we have the script called github.sh. It's using a curl request here that will fetch the build log. So notice that we will pass in user/repo. So this will be Apache/Natex. And we pass in the run ID. This is the job ID. When we pass in this information, the user, repo, and the job ID, we will be able to download the log file in zip format. That's why we see some of the logic here that will do an unzip and so on. And that's it. This is our logic here to download the log files, and we will filter through the log files with this Rust script that we saw earlier on, looking out for any errors and warnings by doing a reverse match. We will not we will skip these lines totally. Any lines that don't match this pattern, there will be a warning or an error message in our GitHub build log. So that was a quick discussion about how we will proceed to build this. This might take a while, but we need it. Like today, we are rolling out a new way of handling NTFC downloads. We are using the pip package manager from Python. But how will we know if there are any errors even after implementing in pip? That's why we need a tool like this to monitor in real time. Unfortunately, the tool is not quite ready yet. We are still building it. That's why monitoring still has to be a bit manual. It's tedious, but we have to do it. And later next month, when we roll out the new mechanism for retrying our builds, we will also need this dashboard to monitor for download errors. We should not see any download errors after we implement the retry mechanism. If we see download errors continuing to persist after our retry mechanism, it means that our retry mechanism is not working correctly and we have to fix it. Therefore, this PR monitor is super important. One more thing that's important, one good way to use this is that in case we ever have peak periods again, like this, we will be able to use this PR monitor to identify which PRs are going through the most builds and taking the most GitHub runners. We do not expect to see any more download errors due to the retry mechanism. NTFC errors would have been fixed by then. But our PRs could be going through a lot of builds because of compile errors. That's where the manual intervention comes in. We still need a person, a human being, to monitor this dashboard, to watch out for high instances of compile errors for any specific PR. Our Natex admin will need to monitor this number here. If our admin sees that any of these PRs are going through too many compile errors, we will have to do a manual intervention. We will have to talk to the developer, ask them to kindly please change the PR status from waiting for review to change it to the draft status. That way, once we change to draft status, we will no longer incur any more charges for our GitHub runners because we have this process here that will kill any jobs in draft PR mode. And when our developer is ready to review the PR, we will change the status back to ready for review mode. Yeah, that's when it will go through a proper compile, and hopefully it will be successful. Yeah, this PR monitor will be super helpful in terms of monitoring our rollout for changes to Natex CI, and also in terms of monitoring our peak periods. That's why this is our next important task now. Today we have completed our analysis of most expensive PRs. I think we are done with our analysis. Our logs are expiring anyway. We need to move on. We are now going to build this dashboard here to help us monitor our PRs, to understand which PRs are going through too many builds, having too many errors, and having too many compile problems, which will need manual intervention. That's it for my discussion today. I've added all the links to these pages in the video description. Please refer to them. I'll update you again in next video about our progress for creating this new dashboard. Thank you so much.